Hello and welcome to a new section. Linear systems we're working on, and in this section we're going to talk about algebraic solution. And there are two methods in algebraic solutions. One is a very straightforward substitution method, and I'm going to show you how to do that. And then the other one is the adding or subtracting, and I need to explain what that is. But some textbooks and some resources, they call that the elimination method. I call all of them algebraic method. Doesn't matter what you call them. Okay, so let's start out with the just to make it simple, elimination method or the adding and subtracting method, and we'll go from there. So the first thing first, notice that the system that I have written for you here, they are written in a different format. First equation has y plus 3x equal to 4. The constant term is on the other side, on the right hand side of the equation. And the second equation is written in a general form. So to do the elimination method, adding, subtracting, you want to have the same type of a form for both equations. So that makes it a little bit easier. So to do that, we're just going to change the second equation and change that to the form of the first equation. And that's just simple to do. Let's go ahead, and we're just going to just basically move the positive 1 to the other side, or get rid of that, so that we have y minus 2x equals to negative 1, and that first equation is y plus 3x equals to 4. Great. Now that we have both of them in the same form, then we're going to go ahead and use the elimination method. Okay, so let's call the first equation number 1, equation number 2, and in this case, adding or subtracting, this is what we're going to do. We're going to subtract the second equation from the first equation, and we're going to do that by basically simplifying like terms. So equation 1 minus equation 2. So that means we're doing this y minus 1, my y minus y has to be written like that. And then we do plus 3x, and then subtraction minus 2x. So we're doing subtracting these two. It's right here. And then the last piece we got to do, whatever we do to one side of the equation, we got to do it to the other side. And so now we're going to do the minus 4, positive 4, and minus 1, that would be 4 minus 1. Now this negative sign is right there. It's right there. That's called the subtraction. And then once we have that, then we need to basically polish that. So notice that the y, they go away. That becomes 0. And then the next thing we're going to have 5x, because 3x minus 2x is 5x, and then plus equals to 4 minus 1, that's 5. Now here is why we use the addition or subtraction method. In this case we use subtraction to get rid of one of the variables. If you have two variables, you can't solve the equation. You need to get rid of one of the variables, isolate one variable only, and then once you get rid of the one of the variables, then it's just easy to solve one variable equation. And look, 5x equal to 5, what is x? X equals to 1. That is called the elimination method. In this case, we subtracted. It is called an elimination method or subtraction method. Some people can call this actually addition. It's just that addition is the inverse of subtraction. It doesn't matter, but that's what you got to do. So now we need to go ahead and solve for y. Now you could have started with solving for y first and then solve for x. It doesn't really matter, but now that we are using the subtraction method or addition method, let's use the same method to solve the other variable. Okay, so here's the thing. We need to solve for y, so we cannot eliminate y. You have to eliminate x. That's what you have to do. But notice that the x value for the first equation has 3 as a coefficient, and it has minus 2x as a coefficient for a second equation. That's the coefficient of x. Well, in order to add or subtract to get rid of these x's, they need to have either the same coefficient, or one could be negative of the other, but the quantity has to be the same. So one could be a positive 3, the other one could be negative 3, but they're not the same. So this is what you need to do. You need to come up with the lowest common multiple of the two numbers and multiply both sides of the equation by that number, so that by that value, by that factor, so that you get the lowest common multiple, and then they will be the same. For example, in this case, the lowest common multiple is 6. So in order to get 6, I have to multiply the top equation by 2, everything by 2. And I have to multiply, so what do I have to multiply minus 2 by to get 6? Same idea, so multiply it by 3. Okay? Now, notice that I didn't do negative. You could have actually multiplied by negative. It doesn't really matter. But at the end, I can just add and they go away. It's simple as that. So let's go through and let's do that by multiplying 2. That means, remember, every single term is being multiplied by that number, the factor in front, so as the second equation. So let's go ahead and rewrite. Okay, so when you multiply the top equation by 2, you get 2y plus 6x equals to 8. Everything is being multiplied by 2. Second equation, everything being multiplied by 3. 3y minus 6x equals to minus 3. Now you notice that we can actually go ahead and name these guys number 1 and number 2. And in this case, we can just simply add the 2, because when we add 6x and minus 6x, they get 0. So 2y plus 3y, that will give us 5y. 6x minus 6x, you're adding them, that's 0. Okay, so you can say plus 0. And then 8 plus minus 3, that is 5. So 5y equals to 5. And now you can go ahead and solve for y, divide both sides by 5. And this is basically grade 9 stuff, right? And here it is. So the final solution, remember, solution comes in ordered pairs. It's a coordinate point, all right? So the coordinates that we have, x was 1, y was 1. And that is the solution to the system that we have dealt with or have at the very beginning. Now, can we check the solution? Let's check. Always you check your solution. So x equals to 1, y equals to 1. How would you check that? You sub into both equations. And they must be true. That means when you sub in x and y for the equation 1, the left hand side, y plus 3x, that should give you 4. And when you plug in 1 and 1 to the x and y for second equation, when you do the math, the left hand side should be 0, and it is. And you can double check, and it is. Okay, here it is. Double check again. Plug in 1 and 1 for both equation into both equation for x and y. And then notice that the left hand side equal to the right hand side, and therefore it works. That's the solution.